All right, we have applications of sinusoids, which is more of just what we did yesterday. A little bit different types of problems. So first of all, read the problem, figure out what you know, don't make up things that you don't know. Like it says at time equals 0, you make contact with an enemy destroyer. Well, we have no idea where we are when we meet that enemy destroyer. So that is extra information. At time equals 0 doesn't even matter. It matters, but in this problem, we don't know. It doesn't mean anything. Then it says we start porpoising, which deeper and shallower, which is going to be a sinusoid, sine or cosine equation. And it tells us at time equals 4 minutes, at 4 minutes, we're at 1,000. It's basically like an ordered pair. So that's where you start. Start with what you know. So on this graph, I know that this is 4. And because I know I'm below it, I'm going to label my graph. Always want to label your graph. So this is going to be time in minutes. We could say minutes, and it tells us it's t, so we need to use the appropriate letter. We use whatever letter it tells us to use, and it told us t. If it didn't tell us t, we could use whatever letter we want. All right, then it says, and that is our deepest below sea level. So this is going to be our distance below sea level. Distance would be fine. It doesn't give us a letter, so you can use whatever letter you want. I'm going to pick B. Now, if I know this is 4, and then I know my y-axis is going to be somewhere over here, okay? And it is at the deepest. So therefore, we know 1,000 is going to be our deepest. And let's see. Let's rewrite this. All right, so we know our deepest is 1,000. So for 1,000, we know that's a coordinate point right there. At 9 minutes, we're at our shallowest. So remember, we have high, middle, and lows. So our shallowest happens at 9 minutes. And our shallowest, it tells us, is 200 meters below. So negative 200. Since that's our shallowest, we know we have this middle. Again, I like to draw a dashed line, not necessary. So negative 200 plus negative 1,000, the middle would be negative 600. That's important because that's going to be our D value in a minute. And if we go from deepest to shallowest after 5 seconds, then another 5 seconds would take us to 14. The middle right here would be 6.5 or 13 over 2. 11.5 or 23 over 2. And then we have a middle, and then we have another low. When it says graph, we need to actually draw the graph. Be sure that concavity is correct and you don't go below the lowest or above the highest. You have that right little curve as you approach those low values. So there's the graph of our sinusoid with everything labeled correctly. Now we're going to use that graph to write the equation. And then we're going to answer these questions. All right. Sine, cosine doesn't matter. Since it looks like a negative cosine to me, that's what I'm going to write. And I chose the letter D because D wasn't given. You could choose whatever letter you want, but you do have to use the T because that's what's given. All right, so D equals. I decided to write a negative cosine. I knew that because I'm going to start right there. So negative, then I write my amplitude, 600 to 1,000, or negative 600 to negative 200. So that's going to be negative 400 cosine, and I need to find my B value. Well, my period is equal to 2 pi over B. I can get the period from this. From 4 to 14 was 10, so 10 equals 2 pi over B. If I can't figure out what that is, cross multiply. 10b equals 2 pi, divide by 10. B equals, always simplify pi over 5. So if you want to put that extra bracket right there, you can. Doesn't matter to me. You are going to have to put it in your calculator in a minute. And then we do have to use the letter T. I, again, decided to start right here, and that is at 4. So minus 4. Close my bracket if I have it. The brackets aren't necessary right there. And then minus my d value, 600. So there is the equation. Y equals would be fine, but you must use the t value. Okay, must use that t. All right, so notice I just put this in the calculator. Look at all those parentheses. Pi over 5 must have an extra parenthesis. So when you're putting this in the calculator, there must be an extra parenthesis right there around the pi over 5. So you must have parenthesis, parenthesis, pi over 5, close, open, x minus 4, because in your calculator use x, close, close. That's what you have to put. Open, open, pi divided by 5, close, open, x minus 4, close, close. Has to be that way in your calculator. Practice that. If you don't practice it, test and quiz day might not be so pretty for you. Calculator won't just find the answer. You have to be able to plug things in correctly. So we want to find t equals 6 minutes and 15 minutes. Well, different ways you could do that. You could go to your blank screen. What I like doing is going to my table. Table of values right there. Go down to equals 6. Now, we always round to the thousandth, so we've got to scroll over and hover over that. We've got to actually get that number to be highlighted so we can see the whole number. Because that's a big number, the whole thing isn't shown up on our table. So we want to know that value. So then we write that down. Okay, now we're writing in words. So when we write words, we don't use negatives. So it'll be 723.607 meters below sea level. Not negative 723 below sea level. That doesn't make sense. It's like moving left negative 3. You can't do that. 723.607 meters below sea level would be the correct way to say that. And then we do the same thing for 15. We could scroll down till we get to 15. If yours doesn't scroll on the Y, that just means you got to go over and scroll up there. Again, go and highlight it, and you get your answer there. The negative just means it's below sea level, which makes sense. The submarine isn't going to fly up into the air. So we have 923.607 meters below sea level. That would be the appropriate way to answer that question. Then it says your submarine is safe when it is 300 meters below sea level. At time equals 0, was your submarine safe? All right, so we've got to look at time equals 0. Now remember, if we were down at like 100, we wouldn't want to scroll up 100, so you can go to your table and we can go back to 0. And then second graph, and that'll show us our table. So it tells us at time equals 0, we were 276.4 meters below sea level. So we were not 300 meters or more below sea level. Therefore, no, not safe. If it asks for an explanation, because we were only 276.393 meters below sea level. Those of you moving on to calculus, get used to that. Writing stuff out. Got lots of writing to do in calculus. If you're not going to calculus, still got to write it out because you're in pre-cal right now. All right, last problem right here. So again, read the problem. I know it's wordy, but read it and figure out everything that you need to know from this one. So this one, 200 million people. Who cares how many people? Okay, that 200 plus million means nothing to this problem. At time equals 0, they jump off a table. The resulting shock wave starts the Earth vibrating on a period of 54 minutes. So it just told us what the period is. Period of 54 minutes. We're going to need that information when we write our equation and graph. The surface moves down from its normal position. All right? So this is going to be distance from normal position. And it doesn't, let's see, does it tell us? Doesn't give us anything. So I'm going to use D again. You can pick Y. You can pick anything but T because that's already been told what it is. Assume that the amplitude is 50. So we know our amplitude is 50. We need that for the graph and to write our equation. So everything at time equals 0, we're in normal position. So this one, 0, the period is 54. We can just write that down. There's no degree symbols. Don't put degree symbols if there are no degree symbols. In this case, our x-axis means minutes. And we have to use the letter T that's given. So label that. Graph and label, that's what that means. Label your x and y axis. Your y-axis distance would be fine. If you are more specific, then it's easier to determine what you're actually finding when you find things out. All right, so the surface first moves down from normal position. So it starts right here. It first moves down from normal position. So it tells us the amplitude is 50. So that means it moves down 50. And then it starts a shock wave. So then it's going to go back to normal. Then if the amplitude is 50, it's going to go back up to 50 and then back down to 54. So there is our graph, which looks very similar to a sine graph. And since it goes down first, that would be a negative sine graph. But you can draw a sine, you can write sine, cosine. It says write a model equation. So sine or cosine, doesn't matter. You pick whatever you like. I'm going to write a negative sine equation because that's what it's set up to do. So I chose the letter D. D equals. If it said function, we would say D of t. If it talks about function, that's when you use D of t, f of x, t of r. All those are function notation, but it just says equation. So distance equals negative a sine. It told us the period was 54. P equals 2 pi over b. There's no degree symbol, so we do not put a degree symbol. Oops, I didn't finish my graph. 27, add and divide by 2, you get 40.5, or you could leave it, what, 80? 81 over 2 would be fine also. 13.5 or 27 over 2 would be fine. All right, so if you don't know what this is, cross multiply, 54b equals 2 pi. Divide by 54. Always simplify. B equals pi over 27. There's your B value. So pi over 27. T, if I start at 0, that's it. There's my equation. C was 0, D was 0. What is the displacement when T equals 21 minutes? All right, when T equals 21 minutes. So we've got to put this into our calculator, our equation into the calculator. All right, so there's our equation in the calculator when T equals 21 minutes. Again, lots of different ways to do this. One way that you might not be aware of, we could go ahead and say we want to store 21 store as x. Okay, because in my y equals, I want to plug in 21 for x. So instead of typing that whole problem in, I can just pull up my first equation. So vars, y vars, y1, I've already stored x as 21, so I can plug that in, and, oh, I did something wrong. All right, so notice the first time I left off the parentheses around pi over 27. So what the calculator did was the order of operations, which was incorrect. So let's fix this now. We still have 21 stored as x. So if we just typed in x, we could see that it's stored as 21. Vars, see if it's right this time. And we get our answer right there. Okay, we knew that answer was wrong. The reason we knew that answer was wrong is because it can't be lower than negative 50. It can't be higher than 50. So if you get an answer that's higher or lower than 50 or negative 50, you knew you did something wrong. That is why I knew I did something wrong. When I typed it into y equals, I typed it in wrong. Okay, so know what you're doing. These make sense. That's what's nice about word problems. They make sense. All right, so our answer would be 32.139 meters below normal. That would be an appropriate answer. 32 meters below normal. What are the first three positive times at which the displacement was negative 37? Again, a calculator problem here. So now we're given y equals. So we go back to y equals. And we type in negative 37 because we want to know when is the function equal to negative 37. So let's graph it and see what happens. We don't see anything on our graph. Okay? See nothing on our graph. Well, let's go to our table of values. Oh, well, look at that. Delete. No wonder we didn't see anything. Negative 37 into y2 and graph. So that looks like a line with a negative slope. Well, we know that negative 50 sine pi over 27x is not a line with a negative slope, and we know negative 37 is a horizontal line at negative 37. So we just can't see anything. So one thing we can do, a little trick, we can hit zoom. Notice there's this little trig button. We're using trig, so zoom 7, and let's see what happens. We can see a little bit more of our graph, but really not much. So let's go to our window. Now, how do we know what our window is? Well, we have this nice graph up above that has one cycle. So we don't care about anything to the left. We want to know the first three positive times. So we know our minimum we want to be 0 for x. Now, our maximum, one cycle is 54, but remember, we want the first three positive times at which displacement is negative 37. So we want to at least double that. So let's go to 100. And then the y min and max, we want y is equal to negative 37, so we need to see at least negative 37. So I'm going to go ahead and make that negative 50. Now we can see a lot more of that graph. Now we can see more than we need to. We need the first three positive times. So those first three positive times are the first, second, and third time it crosses that x-axis. I mean, that line y equals negative 37. So second trace, we want to find the intersect, so 5. Now, I like scrolling. The up and the down will scroll from first to second curve. So I like scrolling on my horizontal line because then I can see that very easily. And then enter, enter, enter. And there's our first point at t equals 7.160 minutes. T equals 7.160, and we are in minutes. Well, we need the next point. Second trace 5. Again, I'm going to go down once, so I scroll on my horizontal line. Enter, enter, enter. 19.84 minutes. And then we do it one more time. Second trace 5. Scroll over to our third positive time. Enter, enter, enter. And 61.16 minutes. Now, recall, we had a period of 54. So once we get from the first to the second, and the third is just the first plus the period. So the 7 plus the 54 took us to the 61 right there. Or we can just use the calculator. Either one will work.